You have a hole that's 1,000 feet deep, and that's a long way to go. So as you're lowering a probe that weighs a couple pounds more or less into the well, you need a way to determine how deep that probe is and a way to easily lower and raise it back up out of the well. What that spool of wire does is it's also got a counter on the front of it. It allows you to easily see exactly how deep that probe is that you're lowering into the well. It's just an easy way to raise and lower that probe into the well. At Pilgrim Hot Springs, the first drilling actually happened in 1979, where 2 wells were drilled down to about 150 feet in depth. And then in 1982, I believe 4 more wells were drilled to deeper depths. The temperature and the pressure in those wells was measured back then, but nothing was really done with those wells until we reopened them in 2011.
This is getting to be a good valve now.
The wellheads were actually rusted shut, so we had to take off those old wellheads and old rusty valves, and we put new stainless steel valves on top of those. And what that allows us to do is actually open up the valves, and we can drop our different probes and instruments down those wells to see how the readings have changed over time. If things are cooling or things are warming. And it's actually been kind of interesting because certain wells have changed temperatures just a little bit, but for the most part, the temperatures haven't changed too much out there.
ASAP took the lead role in providing the research that was necessary to understand the resource so we could develop it and serve the people of the community and the people of the region. And without ASAP, this would never have happened.
It's an impressive system out there. When you're drilling a well, number one, you got to have a way to get those cuttings that are being chipped up by that drill bit deep underground. You got to have a way to get those cuttings back to the surface. And so that drilling mud, that is constantly being pumped down into the well through the drill bit, and then it's coming back up to the surface. And it's collected in a series of tanks. The shale shaker allows the drilling mud to flow through fine mesh that vibrates, and any drill cuttings that are collected are sorted out of that drilling mud and then put in a separate tank. That way you can keep recirculating your mud and you don't have to put new mud in every time. The other thing that drilling mud does is it provides something called hydrostatic pressure. If you can imagine digging a hole at the beach, you usually get to a couple feet deep and then all of a sudden your hole will collapse, and any 6-year-old who's ever played at the beach can tell you this. What drillers have to do is they have to find a way that they can keep drilling down and their hole is not going to collapse on their drill string, because otherwise they lose their drill string and their bit. So when you pump mud and you circulate that mud through your hole, it creates a slight outward pressure so that that hole doesn't want to collapse. That mud is made up of stuff called bentonite clay, and it forms what's called a wall cake on the outside of that hole, which adds hole stability so that hole doesn't collapse while they keep drilling deeper and deeper.
Gwen has been a wonder to work with. Without her, I don't think we would have gotten to this point. Geothermal is basically the only renewable power that can be used as a base load. You'd never do this in the lower 48 because you never have the same conditions you do here. I mean, with the super high cost of electricity, it makes, a 50-mile power line actually feasible.
In the geothermal community, my reputation has really been solidified by working on the Chena Hot Springs project and being associated with the power generation project there, which is about 40 degrees lower in temperature than any other commercial geothermal project in the world at 165 Fahrenheit.
The biggest diameter hole that was drilled this past fall was a 22-inch diameter hole. When you're drilling a hole of that size, you're not just going to drill a 22-inch hole right away. You usually start at about a 6 or a 9-inch hole, and then you might expand to a 12-inch hole, and then to a 14 or a 6-inch hole, and then finally to a 22-inch hole.
Gwen was fantastic in keeping that enthusiasm going and keeping the resources rolling and just a positive spirit around the whole project. It's amazing how much more you work when the environment is positive. And so that's also a very big strength of this whole project. And looking at actually an application that gives back to the community is very satisfying, I think. So that's one more big thing about the project that I wanted to say.
The stuff that they were using out there, it looked big, but it's hard to really get a feel for how heavy and how substantial that stuff is until you're actually there and you actually try and pick up a wrench that they use. Because some of these wrenches that they were feeding onto their drill string to break them apart could easily weigh 50 or 70 pounds, you know, and it's 1.5 inch steel. It's a really, really substantial piece of equipment, and safety is a huge thing out there. Everybody's constantly wearing hard hats and trying to keep track of each other, to be very careful about all their movements as they're moving around the drill rig. Drillers don't like to leave that big long drill string with the bit on the end of it in their hole while they're not actually drilling. Therefore, we were drilling 24 hours a day, and there was 2 12-hour shifts, 3 guys on the drill team per shift. It was going constantly.
The situation here is very different than in Iceland, in that in Iceland they have a national electric grid and everything's connected to the grid. So of course you wouldn't develop a project like the Pilgrim or the Chena Hot Springs project if you had a big grid and had access to other kinds of much lower cost energy sources like hydropower or maybe natural gas generation. But because these are islanded grids, it's a completely different situation. You don't have anything other than the on-site diesel generation to serve many of these sites. And so it's a completely different economic challenge.